Have you ever wondered if nuclear power could be the solution to our current energy crisis? In the face of an ever-increasing global population and a civilization that's becoming more and more reliant on technology, the demand for power is skyrocketing. We are in the midst of an energy crisis, and the need for a sustainable, reliable, and clean source of power has never been greater. Enter nuclear power. A single uranium fuel pellet, no bigger than the tip of your little finger, can generate as much energy as 1,700 pounds of coal or nearly 150 gallons of oil. Nuclear power packs an extraordinary punch, and it does so without belching out the carbon emissions that have been driving up global temperatures and wreaking havoc on our climate. But what about the dark side of nuclear power? We've all heard the horror stories. Chernobyl, Fukushima, catastrophic events that have raised serious concerns about the safety of this energy source. Yet it's important to remember that nuclear power is not alone in its potential for disaster. Coal mines can collapse, oil rigs can explode, and natural gas pipelines can rupture, causing untold damage to both human life and the environment. Every energy source carries with it a degree of risk. What sets nuclear power apart is its incredible efficiency. Consider this: the total amount of waste produced by all the nuclear power plants in the world in a year could fit on a single football field. Compare that to the billions of tons of carbon dioxide pumped into our atmosphere annually by fossil fuel-based power plants. So where does this leave us? Is nuclear power the answer to our energy crisis, or is it a Pandora's box best left unopened? Could nuclear power be our silver bullet, or is it a ticking time bomb? The answer isn't as simple as you might think, but it's a question that we can't afford to ignore. Stay tuned as we delve further into the world of nuclear power, its pros, cons, and the alternatives that might hold the key to our energy future. The story of nuclear power is a story of both triumph and tragedy. Let's turn the clock back to the 1930s, when physicists discovered a phenomenon that would change the world forever: nuclear fission. Imagine the excitement when they realized that splitting an atom could produce 1,000,000 times more energy than any chemical reaction. This was the birth of nuclear power, and it was seen as a game changer, a source of boundless energy that could power our ever-growing civilization. In the late 1940s, we saw the advent of the first nuclear reactors. Scientists and engineers, eager to harness this newfound power, created machines that could control nuclear fission and produce energy on a large scale. The atomic age had begun. But it wasn't until the 1950s that we witnessed the rise of nuclear power plants. These were not just reactors. They were powerhouses capable of supplying electricity to entire cities. The world was awestruck. We had unlocked the secret of the stars, and it was lighting up our homes. The 1970s and 1980s saw a nuclear boom. Countries around the world were building nuclear power plants at a rapid pace. In 2 decades, the number of operational reactors worldwide increased from a handful to over 400. Nuclear power was seen as the answer to our energy needs, a solution to the oil crises, and a way to reduce our dependence on fossil fuels. But it wasn't all sunshine and rainbows. As time passed, we started to see the darker side of nuclear power. Incidents began to occur, casting a shadow over the nuclear dream. The promise of unlimited power was being overshadowed by the specter of nuclear disasters. Despite these challenges, the story of nuclear power is not over. It continues to evolve, adapting to new technologies and safety measures. It's a testament to human ingenuity, a symbol of our relentless pursuit of progress. But as nuclear power grew, so too did the risks. The perils of nuclear power were brought to light by some devastating incidents. Let's take a journey back in time to some of these pivotal moments. First, we land in the late 70s in the heartland of America at the 3 Mile Island nuclear facility. A cooling malfunction caused a partial meltdown of the reactor core, leading to the release of radioactive gases. Though no immediate deaths were reported, the incident sparked public fear and skepticism towards nuclear energy, causing a significant slowdown in its development in the United States. Fast forward to the year 1986, we find ourselves in the Soviet Union at the site of the Chernobyl disaster. A reactor design flaw coupled with operator error led to an explosion and fire that spewed a cloud of radioactive particles into the atmosphere. This catastrophic event led to dozens of immediate deaths and thousands of long-term casualties due to radiation exposure. The fallout contaminated large parts of Europe, and the event remains the worst nuclear disaster in history. Then, in 2011, the world watched in horror as another nuclear catastrophe unfolded in Japan. The Fukushima Daiichi nuclear disaster was triggered by a massive earthquake and ensuing tsunami. The natural disaster knocked out the power supply and cooling of 3 Fukushima reactors, causing a nuclear accident with level 7 on the International Nuclear Event Scale. The disaster led to widespread evacuation, significant environmental damage, and reignited global debates about the safety and viability of nuclear power. These incidents, though isolated, brought to the forefront the potential dangers of nuclear power. They underscored the risks associated with reactor design flaws, human error, and the vulnerability of nuclear facilities to natural disasters. The widespread fear and skepticism that followed these events led to a significant slowdown in the growth of nuclear power. These incidents cast a long shadow over nuclear power, but should they define its future? While nuclear power has its risks, so too do our current energy sources. The burning of fossil fuels, for example, has been a major contributor to global warming. Carbon dioxide, methane, and other greenhouse gases released into the atmosphere form a blanket that traps heat, leading to a rise in global temperatures. The results are far-reaching and devastating, from extreme weather conditions to rising sea levels. But what if we could shift the narrative? What if we could harness energy in a way that doesn't compromise our environment? Enter the world of renewable energy, hydroelectric, solar, and wind power. Hydroelectric power is one of the oldest forms of energy generation. It uses the flow of water to spin turbines, which then generate electricity. It's clean, renewable, and in many parts of the world, abundant. However, it's not without its challenges. The construction of dams can disrupt ecosystems and displace communities. Solar power, on the other hand, harnesses the energy from the sun. With solar panels, we can convert sunlight directly into electricity. It's a silent, pollution-free source of power, yet it's dependent on weather and daylight hours, and storing this energy for nighttime use or cloudy days is still a challenge. Then there's wind power, utilizing the natural movement of air to drive wind turbines. It's a clean and sustainable form of energy. But like solar power, it's weather-dependent, and the turbines can be a source of noise and visual pollution. Each of these alternatives presents a cleaner, more sustainable way to power our world. They're not perfect, but they're steps in the right direction. They offer a glimmer of hope in our battle against climate change. Yet the question remains, as our energy demands continue to grow, can these renewable sources keep up? Are they capable of supplying power on the scale we need, without the environmental impact we can no longer afford? These energy sources offer hope, but can they meet our growing energy needs? So, where does this leave nuclear power in the energy conversation? Nuclear power, in its essence, is a double-edged sword. On one hand, it offers a high-density energy source that can power our cities and industries. It's a low-carbon alternative to fossil fuels, which means it could help us combat the escalating climate crisis. Moreover, advancements in nuclear technology promise to make it safer and more efficient than ever before. The potential for nuclear fusion, for instance, could revolutionize the energy landscape, providing us with near limitless power without the risks associated with current nuclear fission processes. On the other hand, we cannot dismiss the challenges and risks tied to nuclear power. Incidents like Chernobyl and Fukushima have demonstrated the potential for catastrophic consequences when things go wrong. The radioactive waste produced by nuclear power plants remains dangerous for thousands of years, posing a significant challenge for long-term storage and disposal. Furthermore, nuclear power plants are expensive to build, and the fear surrounding nuclear energy, though arguably inflated, is a real obstacle to its wider acceptance. The key point to remember here is that there's no silver bullet solution to our energy needs. As we move forward, we need to diversify our energy portfolio, combining multiple sources to meet our power demands while minimizing our environmental impact. This means harnessing the power of the sun, wind, and water through renewable technologies, but it also means considering nuclear power as a part of the mix. In this vein, it's crucial to continue research and development in nuclear technology to make it safer, more efficient, and more acceptable to the public. We also need to build a robust regulatory framework that ensures the safe operation of nuclear power plants and a fair and effective system for dealing with nuclear waste. The energy crisis demands solutions, and nuclear power, despite its past, may still have a role to play.